Hello, and welcome to Ansys's presentation on best practices in simulating electronics reliability. Why do we care about electronics reliability? Because it's increasingly more difficult to design electronics. All the major technology trends, 5G, autonomous, electrification, industrial Internet of Things, all demand more performance, smaller products, and lower cost. The result, we're seeing higher power in today's electronics, higher speeds, increasingly smaller packages, demands for performance at higher temperatures, demands for performance under more strenuous electromagnetic radiation, and the ability to do all this while still maintaining very high reliability over long periods of time. And we want to talk about simulation and electronics reliability because we know, and we've demonstrated through multiple case studies, that when we use simulation to evaluate electronics reliability early in the design process, we see enormous benefits. Benefits in terms of performance, benefits in terms of reduction in design cycles, benefits in terms of reducing material costs. How do we do this? How do we do simulation of electronics reliability the right way? The best way is through Ansys's broad range of simulation tools that combine to provide an unrivaled workflow to give organizations and users worldwide the ability to do comprehensive multi-physics solution simulations all the way down from the transistor level to the chip, to the package, to the PCB, into full and complete systems. And we do that by evaluating reliability from an electrical perspective, thermal perspective, mechanical perspective. We capture all those from our reliability physics, and we allow all those reliability simulations to interact with each other to provide a comprehensive multi-physics solution. And we do this in a variety of ways. If we look at electrical reliability, right, there are a number of challenges when it comes to electrical reliability, whether it's improving power and signal integrity in today's devices, minimizing EMI risk, or improving antenna performance. Ansys has the capabilities of solving those challenges through robust simulations, system-level ESD analysis, and direct current insulation resistance-based thermal analysis. The results, dynamic checks on electrostatic discharge sensitivity, connections with thermal and mechanical reliability solutions, and possibly the most important, early detection and mitigation of risk due to EMI EMC failures. Thermal reliability addresses its own challenges, whether optimizing cooling strategies or addressing thermal management at multiple scales, from chip to package to PCB. How does Ansys address those challenges from a thermal reliability perspective? Really with unrivaled comprehensive electrothermal and thermostructural multi-physics simulation capabilities. The multi-physics capabilities offered through Ansys's thermal reliability tools are unrivaled. And what's really exciting is the ability to provide that unrivaled connection between electrical and thermal, and then present it in a reduced order modeling to extract that information and present it to system level. Great examples of outputs from this thermal reliability simulation include obviously temperature prediction of components, but really enhanced and optimized cooling strategies. Only pay for the cooling strategy you absolutely need. How do you do that? You need accurate thermal simulations. The thermal simulations need to tell you what the effects are from an electrical and mechanical perspective, and all three need to connect in terms of reliability prediction. Ansys obviously is the world leader when it comes to mechanical reliability simulations, and that's nowhere more true than in electronics. Really, Ansys is the only tool provider in which its mechanical reliability tools focus exclusively on electronic designs, and processes to provide users an easy and robust methodology for evaluating the mechanical reliability of electronics. And this is more important than ever because physical testing is increasingly expensive, is increasingly time-consuming, time that most design teams can't afford in terms of rushing, in terms of addressing time to market needs. Like I said, Ansys capabilities are unique in that they provide very direct and specific abilities to model both the PCB and the components, and provides extremely advanced solvers to address some of these really complex mechanical simulations. The result is an extremely streamlined workflow that provides very accurate understandings of product performance under a broad range of thermomechanical and mechanical conditions, such as temperature cycling, thermal shock, vibration, and drop. What we like to do here at Ansys to provide value to our customers is bringing all these world-leading tools, electrical reliability simulation, thermal reliability simulations, and mechanical reliability stations, bring them all together and provide our users clear insight into what it all means. And that is the linchpin of reliability physics analysis. When we look or we perform electrical reliability simulations or thermal reliability simulations or mechanical reliability simulations, we have to ask ourselves, so what? What does it all mean? By taking it the final step and doing actual predictions through our unique reliability physics tools, we connect true costs, BOM costs, design costs, to savings or costs out in the field, warranty costs. So now one can design your product to meet your reliability goals and no more and no less. And then all these tools, in an amazing way, talk to each other, communicate with each other, are tightly integrated with each other. This interaction of multiple physics, of which the core is Ansys IcePack, really allows customers to optimize product performance and provide deep insights in their products in ways never seen before and far earlier in the design process. This comprehensive multiphysics allows customers to truly push design based upon robust simulation, as opposed to simulating whatever the design team has come up with. And by connecting all these different simulation tools together, it increases collaboration across the enterprise. Like we said, when you do simulation the right way, the benefits are measurable and amazing. One customer, Danfoss, by using Ansys Sherlock, the leading reliability physics tool for electronics, they reduced their time to market by 75%. That's amazing. In addition, another leading chip manufacturer reduced their simulation time by over 2,000x. And that's really critical, right? To really get deep understanding of performance of your electronics, one needs to do simulation at multiple steps in the product development process and provide as much detail in the simulation as possible. Many enterprises are often hesitant to do this because they're concerned about the time required to do this. By utilizing Ansys' IcePack and Ansys' reduced order model capabilities, engineers exploit this capability to provide full CFD simulation far faster than before. It really makes simulation, the possibility of simulation, to be deeply embedded in the product development process. And finally, an antenna developer reduced their material costs by 20% by optimizing the design before building any prototypes. And you can read about all the case studies here in this presentation. So we provided a broad range of resources for you to learn more about electronics reliability, including white papers, application briefs, customer stories, comprehensive webinars, tips and tricks, and our own unique Ansys Learning Hub, I especially would point you to the white paper on SAE J3168, which is describing how the automotive supply chain is increasingly moving towards standardizing simulation, not just physical test, as the final step in validating any products going in today's vehicle. As time to market reduces in the automotive space, but complexity rises astronomically with the introduction of autonomous electrification, the need for a simulation interchange between supplier and customer is increasingly necessary. So for the rest of the presentation, let's just do a brief overview of each of the capabilities and break out what they're able to bring in terms of simulation best practices. When we talk about electrical reliability, what really makes Ansys electrical reliability tools stand out is their ability to do an extensive range of simulation capabilities to capture all types of performance and potential risk issues, and to do that at multiple levels within the product, specifically around our chip package system capability. So whether it's power integrity or reliability, simulation can start at the transistor level, work all the way to the system, and their abilities within the Ansys toolset to do these simulations in a way that you can carry them from one level to the other. And you can also couple these chip package system interactions to ensure full product functionality. Some examples include signal integrity analysis, which is increasingly critical as one goes to higher speeds, especially for the latest memory technology. What we describe as DCIR-Thermal Simulation. I think this is one of the cooler workflows within the Ansys product family. Here, in a tightly coupled interaction, one can compute DC voltage and DC current density in Ansys SI Wave, send that to Ansys IcePack. Ansys IcePack then sends that information back to Ansys SI Wave to update material properties, right, especially of the copper, which updates the current density, which then results in a new computation. This thermal aware approach provides really the industry-leading most accurate identification of current density and temperature at the chip, package, and even board level. And more recently now, within the Ansys family, one can take that information and compute electromigration failure rates and lifetime. EMI simulation, probably the most critical aspect of any kind of electronics reliability. Within Ansys, EMI simulation is just one part of a three-legged stool, including signal integrity and power integrity, to make sure that your device and your PCB and your system works under a broad range of electromagnetic radiation situations. These simulations, under the auspices of electrical reliability, provide clear, quantifiable benefits. Like all simulations, but especially electrical reliability simulations, it reduces the number of board spins. It's going to improve product reliability, especially through the unique capability of thermal-aware electromigration simulation. And it really guides designers in the earliest stages possible on how to improve EMI, EMC, and ESD risk mitigation for both device, package, and PCB level. Under thermal reliability, Ansys provides what you need, because there's really nothing more important than thermal reliability when it comes to electronics. Almost every kind of performance or failure mechanisms that drives electronic reliability in some way, shape, or form is influenced by temperature. So the accuracy of knowing that temperature in your electronics and controlling it effectively is paramount. Ansys does this more effectively than any other tool set on the market because it can offer it at every single scale within the overall electronic system, from transistor and chip to package to board and assembly to box level, and finally to full system or even data center level. And by using Ansys's unique reduced order models, physics-based behavior can be carried from one level to the next in a way that's portable, fast, and effective. Some examples of how thermal reliability is done within the Ansys toolset, just some examples right here. One is our unique ability to do PCB thermal reliability. We provide very high fidelity PC modeling capabilities, unique in the industry. There's a broad range of how one can capture thermal conduction and convection behavior at the PCB level. Our unique orthotropic conductivity map can capture trace, via, plane, and pad data for each layer, and very accurately capture these thermal pathways to get very accurate temperature predictions for every single device on the PCB. Thermal reliability, as I said, is really the core or the crux of a lot of our reliability concerns when it comes to electronics. And Ansys realizing that makes Ansys ISPAC really the core, the foundation of our multiphysics interaction within all our electronics reliability tools. Whether it's Ansys Maxwell or Ansys SI Wave, Ansys Red Hawk or Ansys Sherlock, ISPAC talks to all of them in creating these robust workflows that ensures that you've not overlooked anything in regards to electronic reliability for your electronic system. And all these approaches in terms of thermal reliability, again, just like electrical reliability, provide clear, quantifiable benefits. Thermal reliability starts with accurate thermal models. Ansys ISPAC, unlike any other tool, imports a wide array of formats for ECAD and MCAD, and pushes down into very efficient and effective model creation. So you can decide the level of detail you need within your thermal model and control that in ways unrivaled by any other tool. You can do that analysis, like I said, at every level of the electronic ecosystem. And the unique coupling between Ansys ISPAC and the other Ansys tools, especially Ansys Mechanical and Ansys Sherlock, allows engineers to truly understand how to optimize that thermal design. If you run thermal analysis in a standalone tool, all you know is temperature, which is one thing, but it doesn't really tell you what it means in terms of reliability. And at the end of the day, that's why you're trying to determine temperature. Otherwise, just using kind of old-fashioned and outdated thermal rating tables that provide little to no value to the organization. By coupling with Ansys Mechanical and Ansys Sherlock, Ansys ISPAC really closes that loop. If that heatsink is cheaper than another heatsink, you can compare the price savings on making that switch or the price increase to changes in potential warranty returns, which is analysis not available among any other workflow. For mechanical reliability, Ansys is open and is aware of the deep simulation challenges mechanical analysts have in simulating electronics. Most electronics nowadays, especially for the leading technology trends, have an amazingly large number of components with very complex geometric details, very complex PCBs with many features, and numerous materials, including metals, ceramics, and polymers. Ansys provides truly best-in-class solutions for taking information from the ECAD, integrating it with embedded libraries, and automated workflows to provide you, the user, amazingly quick and accurate models of those ECADs that are ready from stage one, that are simulation ready, even for the most complex physical simulations. How do we do this? Just some examples. Best-in-class PCB modeling. Using Ansys Sherlock and Ansys Mechanical, you have a broad range in terms of how you wish to address your PCB in your simulation model. Whether you want to use lumped models that capture material properties over the entire board, trace mapping, which uses an overlay mesh, new reinforcement capability, which allows you to model all the traces and vias within a PCB, or even trace modeling, which models all the traces and vias in a 3D structure, especially for relatively small areas. Each of these provide improvements in terms of, or trade-offs in terms of speed and accuracy, but only under Ansys do you have all those capabilities within one tool set. Once you have the geometry and material properties set up, which occurs almost seamlessly within Ansys, you have a broad range of simulations one can do to evaluate a range of possible risks in terms of electronics reliability, whether it's solder reflow and warpage, moisture effects, shock and vibration, or even drop and tumbling. All these static and dynamic behaviors can be captured accurately within the Ansys mechanical reliability family. And just like thermoelectrical, these features deliver clear, quantifiable benefits. How would you like to know way up front in the design if there's any risk in terms of any environment your product might see from a mechanical perspective, and avoid that issue way up front, even at component selection, right? And then how would you like to reduce the amount of physical testing you're currently required to do, not just for initial launch, but also with to deal with future changes, right? In the automotive industry, changes are done on an annual basis, and the cost to revalidate those changes can be north of $100,000. Think about the cost and time savings if you could replace that with reliability, mechanical reliability simulation. We take all those, as we talked about, and we bring them into reliability physics, the mechanical reliability, the thermal reliability, and electrical reliability. Why? Because we're trying to break the old workflow, right? Or the old design, build, test, fix. This process doesn't work, right? And with the simulation capabilities we have today, really should never be done in the first place. One should simulate, then design, and then build, and then sell, and then make money. And we do this through our reliability physics capabilities. The linchpin of the reliability physics workflow within Ansys is Ansys Sherlock. It's a tool we use specifically for electronics to help users really mitigate almost any kind of failure mechanism that could occur from electrical, thermal, or mechanical loads, and works in tight integration with a number of other Ansys products, especially Ansys IcePack and Ansys Mechanical. By using Ansys Sherlock in combination with these other Ansys tools early in the design process, it opens up huge opportunity in terms of improving the overall electronic design workflow, especially using it as early as initial part selection. Pick the right parts at the right time. Just like the other tools, it provides clear quantifiable benefits, especially the manufacturability capabilities can improve first-class yields and reduce manufacturing defects. But most importantly, it really ties the value of simulation back to the bill of material cost, right? Know those trade-offs and optimize the design before you ever go to first test. And all this works because of an unrivaled workflow, as you can see here. Starting with Sherlock to utilize its best-in-class pre-processing to feed into IcePack and Ansys Mechanical. All four of these tools work closely together to provide you unrivaled insight in terms of the electrical, thermal, mechanical, and physics-based reliability of your electronic device, package, board, and system. I said no better example of that is the Electro-Thermal Analysis tight integration between SI Wave and IcePack and HFSS and IcePack. The ability to run those electrical simulations, capture those electrical loads, feed them for thermal simulations, and feed that back to account for temperature dependency and material properties. It's unrivaled anywhere else. It ensures a high level of accuracy for both the electromagnetic and thermal simulations. And finally, all these tools work together to optimize the performance of your electronic systems. You're using not just the SI Wave and Mechanical and IcePack, but also Ansys OptiSlang. One can investigate a variety of parametric design variations and determine optimal configurations. What is the optimal design of your heatsink? How should you attach that board to your enclosure? You can base it on some rough understanding of previous success, or you can make sure that you're successful the first time up based on robust physics analysis and reduced order models through design optimization. There are a number of examples that we have that shows clear quantifiable benefits when using this comprehensive multiphysics workflow for both electrical thermal, thermal structural, and dynamic power management issues. Want to learn more? This matrix here shows you all the Ansys products that we cover under electronic reliability simulation and allows you to correlate those products to the capability and specific applications that solve the problems that you or your organization might be experiencing. We're looking forward to hearing from you.